All right, hello everyone. This is an example for the cytotoxicity assessment, which is section 4 of your lab report. So each student has been allocated a distinct data for the cytotoxicity of a magnesium alloy. The composition is different. So if you look at the data that has been allocated to you, we have two values for the control group, which is day 3 and day 5, and then we have a cell viability values for magnesium alloy extract after day 3 and day 5. So I will explain a little bit how it works. We have three wells for control group day 3, three wells for control group day 5, and similarly we have three wells for day 3 and day 5 of magnesium alloy extract. So in the control group we just add a cell culture medium in the well, and then we seed some cells. So in this case we have osteoblast like cells, like bone cells, that were seeded in these wells. So control group, they didn't have any magnesium alloy samples. Whether in other case, magnesium alloy extract, well 1, well 2, well 3, in these cells we didn't add any cell culture medium, and instead of that we just added the magnesium alloy extract that was dissolved, magnesium alloy that was dissolved in the cell culture medium, and we added that solution in these wells, and then we seeded osteoblast like cells in these wells, and then we measured the cell viability of each group after day 3 and day 5. So all you need to do is to take average of each group. So we will start with the control group day 3. So we just apply the formula average for each group, and then we have a standard deviation value for each group. All right. So here we have rearranged this data. So we will do day 3 first, the control group for day 3, and then we will do magnesium alloy extract for day 3. Put these values here, their standard deviations, respective standard deviations, and then we have control group day 5, and then we have magnesium alloy extract day 5. So we just need to plot them. So this can be done easily. So we will just plot their average values first. So you can see here, so these values can be easily plotted, and then you have to add their standard deviation values. So you can do add chart element, error bars, cluster, specify values, delete, and then we add these standard deviation values for all of these groups. There we go. All right, so this is how you will actually plot this graph. So I will just delete it because I have already plotted this here. So if you see, we have the vertical axis, we have cell viability in percentage. So we can do 0 to 110, and in the interval of 10%. All right. So here we have on the x-axis, we have label for each group. So now I have also uploaded ISO standard on Canvas. So you can see this, the number is 10993-5-2009. So if you go to page 18 of this standard, it's written that if relative cell viability of 100% extract of the sample is greater than 70% of the control group, then the material should be considered non-cytotoxic. So we have to analyze whether the cell viability of magnesium alloy group, it is 70%, it is more than 70% or not. So we can do one thing, just insert maybe one straight line and press shift, go to 70%, and just draw a line here so it can be a threshold. So we can make it a red color, increase the weight a little bit, maybe make it a dash line so that is more clear. So we can see that after day 3, the cell viability of this magnesium alloy was above 70% threshold. So it was non-cytotoxic after day 3. But after day 5, but we have observed that this particular magnesium alloy, the cytotoxicity was below the threshold value of 70%. So some magnesium alloys, they exhibit biocompatibility, so they are not cytotoxic after a certain period of time. Some magnesium alloys, because they include some cytotoxic elements in their compositions that have been added as underlying materials, so they can exhibit